Everyone, my name is Simon, and today we will be discussing the topic of symmetry. Now, symmetry can be divided into two different parts. The first part being line symmetry, and the second being rotational. Now, line symmetry is when an object or a shape can be divided into two identical pieces. This is also known as reflection. Now, rotational symmetry is when an object or shape is able to coincide with itself in a rotation of less than 360 degrees. By level 3 in the scope and sequence of OSVALs, students should already know how to identify symmetry in the environment. This can be aided by identifying angles as a measure of turn in relation to understanding rotational symmetry. As students further progress towards level 4 and 5 of OSVALs, students are expected to be able to create their own symmetrical patterns along with describing the reflections and rotations of two-dimensional shapes, thus being able to identify line and rotational symmetries. Important keywords in symmetry are half, shape, similarity, line, turn, and rotate. It is important to note that not all shapes and objects have a symmetrical value. These shapes and objects are known as asymmetrical. Here's an example I prepared earlier comparing that of a symmetrical object and that of something that is asymmetrical.
Symmetrical, asymmetrical.
Here are some examples of activities that students may do in the classroom.
The first activity will be focused on recognizing line symmetry in two-dimensional shapes. This will be done through students cutting out shapes and folding them to see how many lines of symmetry each shape has. For example, this triangle only has one line of symmetry. This, on the other hand, is asymmetrical. Now, a circle has an infinite amount of lines of symmetry. In relation to rotational symmetry, this activity will have students demonstrate how many times each certain shape can coincide with itself in a rotation of less than 360 degrees. Looking at this flower can rotate, starting from here, 1, 2, 3, 4, 5, 6, 7, 8 times. Whereas this banana has no rotational symmetry. It can only coincide with itself at a 360-degree angle and no less. To further extend upon this learning criteria and activities presented, having students do a line symmetry task involving drawing the other half of this picture can assist in both their understanding of symmetry along with spatial awareness.
Other activities such as finding and discussing where we see symmetry in everyday life can assist in building their understanding of how symmetry works and where it is. To justify as to why these activities have been chosen, activities that provide a hands-on and visual stimulus help aid in educating students, especially those with learning difficulties. Visual and physical aids in the classroom are also considered powerful ways of building student engagement and retention. In doing so, this may also promote a greater level of independent thinking. Common misconceptions related to symmetry are that students either count more or less lines of symmetry that actually exist. An example of this is the rectangle, where students may count 4 lines but there are only 2 lines, 1, 2, that are able to create an exact mirror image of the other. Another misconception is the use of triangles in symmetry. The misconception is that if a student sees an equilateral triangle and notes the lines of symmetry present, he or she will think that all triangles have the same amount of symmetrical lines. This is not true, as for example, this isosceles triangle only has one line of symmetry. Thank you for watching this video. I hope you have learned something. Until next time. Oh.